Alright, perfect competition is the big topic in micro, so here we go. We've already seen where these cost curves come from, so this is going to be our representative firm in perfect competition, and this is going to be the market. So we going to have a market graph and a firm graph. And when I draw these out, I draw them side by side like this, although for this I'm going to zoom into to one of these graphs as we go through it so we can see it better. So we have this market. So what makes it perfectly competitive is that there's enough firms, there's a lot of firms, and enough so that each individual firm essentially has no impact on the market, cannot affect the market price. You're one out of 10,000 wheat farmers or something like that, and doesn't matter what you do with the price or how much you produce, you're not going to be affecting the market as a whole. So the market as a whole is here just an ordinary supply and demand graph, and we have a bunch of demanders of wheat, for example, all summing up to this market demand curve, and we have all of our individual firms summing up to our market supply curve, and we're going to look at more carefully where the supply curve is coming from now. And so that's what determines the market price. And our firms, because they're such a small part of the market, they are what's called price takers. They can't do anything about this market price except accept it and decide how much they want to produce. They could always try to increase their price, but they're not going to sell any because there are so many other sellers willing to sell at that market price, and they would have no reason to drop below that price because the market can absorb all of their output at this market price. So they're just going to take this price and get as given, and depending on their cost curves, that's what's going to determine what they're going to do and how they're going to profit maximize. So let's just zoom in a little bit to this firm graph. Again, we've already seen where these cost curves come from. And so remember, this is just the market price. The firm is just taking this price as given. And even though the market demand curve and all of our individual demand curves that sum up to this market demand curve are downward sloping, the firm faces a perfectly elastic demand curve. So remember, a downward sloping demand curve is essentially telling you if you want to sell one more unit, you're going to have to drop the price. Well, a perfectly competitive firm does not have to drop the price to sell one more unit because we've assumed it's such a small part of the market. It can sell all the output it wants at that price. So the firm faces a perfectly elastic demand for its product. Again, even though every demand curve in this market, all of our individual demand curves and our market demand curve is downward sloping, the demand curve facing the firm for its output is perfectly elastic. And that also means that the marginal revenue of this firm, so remember, marginal revenue is just the change in total revenue for a change in output. So if this firm sells one more unit of output and it's just a price taker, then every extra unit of output is just bringing in that price. So the change in revenue is just the price. And so for a perfectly competitive firm, selling all of its output at the same price means that marginal revenue equals the price. And average revenue is just total revenue divided by quantity. It's just the per unit revenue. And since we're selling every unit at P1, average revenue is also equal to the price. So that's why the little mnemonic here, just to remember what this represents for perfect competition, Mr. DARP. So we have marginal revenue, which is this line here, is equal to the demand curve facing the firm, equal to average revenue, which is equal to price. So just write it out like this to sort of remember what's going on here for perfect competition. Now, I'm trying not to use too much text here, but just to go through a couple of things. Now we want to maximize profits, right? So how does a firm decide what to produce? It's going to be making a marginal decision here. Do I want to produce one more unit? And so to produce one more unit, I want to look at what is the extra revenue, the marginal revenue of that extra unit, and what is the marginal cost of that extra unit. So remember, this is now marginal revenue, this is marginal cost, and if marginal revenue is greater than marginal cost, then I want to produce one more unit. So to profit maximize, I'm going to keep producing as long as marginal revenue is greater than marginal cost, or in other words, if I have nice continuous curves here, I'm going to go right to that point where marginal revenue equals marginal cost. So I'm producing all these units for which marginal revenue is greater than marginal cost, because if I kept going, the next unit, right, that quantity past Q1, the marginal cost is here, the marginal revenue is still on that line, so I'd be losing from that next unit, so I'd want to stop here, set marginal revenue equal to marginal cost. And we just said for a perfectly competitive firm, marginal revenue is the same as price, because again, I'm selling one more unit. What's the extra revenue that I'm bringing in for that next unit? It's just the price. So price equals marginal revenue, which means for a perfect competition, the profit maximizing rule becomes this: set your price equal to marginal cost, which is the same thing. So price equals marginal revenue. We're comparing price to marginal cost. If price is greater than marginal cost, I'm going to keep producing. So I just take that P, set it equal to marginal cost. That's how I determine my profit maximizing quantity. Now, profit. So the definition of profit is just total revenue minus total cost. And I want to get it in per unit terms. So I'm just going to divide everything by quantity, which gives me profit per unit. My total revenue divided by quantity. Now that's average. So if it was change in total revenue over change in quantity, that would be marginal revenue. But if I'm just taking the total divided by quantity, that is average revenue, the revenue per unit, right? And this is just cost per unit, or in other words, average total cost. And average revenue, since I'm selling all of those units at the same price, that's just the price, right? Total revenue divided by quantity. This is price times quantity divided by quantity. So that's just price, so equals average revenue, right? We're reminding ourselves of that by writing out Mr. DARP. So the more common way to write this out is just the difference between price and average total cost. And I can just take that per unit profit and just go back to total profit, right? So this is just per unit profit times quantity, the difference between price and ATC. So for every unit that I'm producing, I'm getting P1, and on average I'm getting P1, and on average it's costing me this because I'm on my average total cost curve at this quantity, which means at this particular quantity and price I have zero profit. Now remember, when we're talking about firms, we're always talking about economic profit, which means that these cost curves are including all of our opportunity costs, so that we are doing just as well as whatever our next best alternative might be, which means that we would have a positive accounting profit. So if this firm were reporting its earnings according to normal accounting standards, then it would be earning a positive accounting profit. But once we subtract out some of those costs that are not included in that, some implicit costs, in particular cost of time, other implicit costs, it could be implicit cost of capital, we're going to subtract out all those implicit costs, and that leaves us with zero economic profits. So when we talk about zero profits here, we're always talking about zero economic profit, which means we have a positive accounting profit.